Okay, so we've been working with quadratics, and today we're going to actually look at graphs of quadratics. So you know when we've been solving our quadratics, we've been solving with the square root method, completing the square, quadratic formula, and factoring. Well, when we solve the quadratic, you know those answers we've been getting? Well, what they are is where the graph touches the x-axis. All the answers we've been coming up with is where the graph touches the x-axis. Let's see if I can find a paper where I have something on there where we did it and it came out kind of nice. Okay. This one wasn't too bad. Okay, so this one we did the other day with completing the square. And when we completed the square, we got down to 7 and negative 4. So let me show you this graph real quick. Now, with the calculator, and you don't have to do this, I'm just going to have you watch. With the calculator, they do have to say equals 0 before you can put it in. So I'm going to put in x squared minus 3x minus 28. I'm going to graph it. And where it touches the x-axis, those are the solutions. So let's see if we can count it. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4. And that's a negative 4. And those are our answers. A positive 7 and a negative 4. So all those solutions we've been getting, that's where these quadratic graphs touch the x-axis. And those are called the solutions. You guys would have learned this in Algebra 1 and maybe talked about it again in MMA. I'm going to see if you remember. These guys right here, they have 4 names. Solutions is one of them.
Vertex?
No.
Well, that's the point of it.
They're roots, zeros, x-intercepts. So, she's in Algebra 2.
Yes.
However, you learn it in Algebra 1 as well, and I don't know if they go back over it in MMA. So they're called solutions, they're called roots, they're called x-intercepts because they're on the x-axis, and they're called zeros because what's your y value here and here? 0. That's why they're called zeros. Like if I went and I looked at the table, if I look at my 7, that's one place where it crossed the x-axis. That's where your y value is a 0. That's one reason why it's called a 0. And negative 4 was the other one. So you can see that your y value there is also a 0. So that's what we've been doing all along. We have been deciding where these graphs touch the x-axis. We just haven't been talking about that specifically. Okay, so we're just going to practice a little terminology today. We're not actually really doing any calculations, so hopefully you'll like this. When a parabola opens down, the highest point is called a maximum. When a parabola opens up, the lowest point is called a minimum. And that highest point and lowest point, they're called the vertex. Do you remember that from your past? Okay, so that's the vertex, and it's a maximum because it's the highest point. That's a vertex, and it's a minimum because it's the lowest point. And then another thing that we're going to talk about today is the axis of symmetry. The axis of symmetry is the line that splits the parabola in half. Now, for both of these, it's the y-axis that splits the parabola in half. Does anybody know the equation of that line right there? I know he's the y-axis, but does anybody remember his equation?
A squared plus B squared.
No. Do you know the equation of this line I just drew right here in orange?
Y equals X equals 0?
Nope.
Wow, this is a sad day. Can you tell me what the ordered pair is for that point right there? Negative 3, 0. Do you know what the ordered pair is for that point? Negative 3, your left 3, and your up 1, so negative 3, 1. Can you tell me what the ordered pair is for that point right there? Negative 3, negative 2. I could keep doing this all day. Do you notice anything they all have in common?
Y equals negative 3.
No.
X equals
X equals negative 3. See how all of them have an x value of negative 3? So this line right here is called x equals negative 3. Because everywhere on this line, the x value has a value of negative 3. Well, what's your x value everywhere on this line? 0. This line right here is x equals 0. That is the axis of symmetry for this parabola, and x equals 0 is the axis of symmetry for this parabola. Anytime you have a vertical line, the equation is x equals something. Do you remember that from your past? Horizontal lines are always y equals something, and vertical lines are always x equals something. Okay, and then another thing we're going to talk about is something's reflection point or corresponding point. If I took this point -2, -4, and flipped it over the axis of symmetry, he'd land right here. This is called its corresponding point or its reflection point. Okay, so in here I talk a little bit about the axis of symmetry, that it's a vertical line that splits your parabola in half, and then axis of symmetries always have an equation of x equals something. It just depends on where you are. Okay, and then I talked a little bit about the corresponding point and reflection point. So let's just get going, and then there's something else I'm going to add to this. All right, so remember, the vertex is either the highest point or the lowest point. So this guy right here, this is my vertex. Can anybody tell me the ordered pair for that point?
0, 2?
No.
2, 0.
2, 0. You go right 2 to get there, and then you don't go up or down. So that's 2, 0. Would you say that this is a maximum value or a minimum value? A minimum value. Okay, the way the max or min value goes is you want the y coordinate of the point. What's the y value here? The y value is 0, so the minimum is 0. When I want to know a max or a min, I want to know how high I am or how low I am. And what talks about how high and how low? The x coordinate or the y coordinate? The y coordinate talks about how high or how low you are. So whenever you talk about a max or a min, you always want the y value because it's the y value that talks about how high or how low. Harris, you planning on paying attention to me at all today? Okay, the axis of symmetry is the vertical line that splits the parabola in half. Anybody want to tell me what that is? X equals 2. All vertical lines are x equals, and everywhere on this line the x has a value of 2. So the axis of symmetry is x equals 2. Okay, well, now what it wants here, it doesn't want the ordered pair of p. It wants to know what would the new p be if you flip it over the axis of symmetry. So if I have to go right 1 to hop on the axis of symmetry, I'd have to go right 1 more to get to his reflection point. That's the p it's looking for. So what would you say that is? 3, 2, because you go right 3 and up 2. Okay, and then Q, it wants to know where would he land if you flip Q over the axis of symmetry. Can you tell me without me telling you?
1, 6. Nope.
0, 8.
How would you do that?
Because to get Q to the axis of symmetry, I would have to go 2 to the left to hop on the axis of symmetry. So I go 2 more to the left to get to his reflection point. They're the same distance from the axis of symmetry as one another. And so that's the new Q, and that would be 0, 8.
I thought this was geometry.
Well, yeah, but we're in an algebra review right now. Remember? We stopped the geometry for a little while. We're in an algebra review. Because it's fun! Now, one reason you need to know this. On Monday, we're going to graph parabolas. And so we're going to graph parabolas by Tuesday.
Oh, no, what's happening?
When you plot a point, we're going to flip it over and get its other point. So that's one reason why I'm talking about that today. Okay. Students tend to not do very well with domain and range. And I'm going to show you something today that you haven't done yet in your past, but in your past you would have talked about domain and range and you might be a little weak about it. Do you remember, is domain about x's or is domain about y's? Domain is about x's and range is about y's. When I taught Algebra 1 last year, I told the kids that it was Dr. XY. Domain is your x and range is your y. Dr. XY. I thought so. Okay. What's what? Her laugh? She laughed. Was it evil sounding to you?
Oh, it sounded like something that Gizmo from Gremlins was.
Oh, from Gremlins? Have you not seen Gremlins? You have to watch Gremlins. It is such a good
Gizmo
movie.
sitting in my room. It's motion censored, and when he sings, it moves his head back.
I tried to get my daughter to watch it, but she's a pansy, so she won't do it.
I don't
So one of these days, I'm going to strap her down. Well, it's a little scary in places, but it's so good, it doesn't even matter.
I love it so much.
And they're so cute, these little gremlins.
He's in the front yard.
They just have to see him. Oh, you have to see it. All right, back to this, or I'm never going to finish. All right, so domain is about your x's, and your x-axis is left and right. So I want to know, what is this graph doing left? If I was to start cruising left, would you tell me that this graph would go forever to the left?
Yep.
It does. And then if I started moving right, would you tell me that this graph goes forever to the right?
Yep. Because
Okay.
it's an arrow, not a dot.
Yes, because of the arrows. So if a graph goes forever to the left and a graph goes forever to the right, we call that all real numbers. And you would have learned an abbreviation for it.
The AR thing.
Yes, that guy right there. Now, I talked to the teachers that teach the regular Algebra 2 class, and right now this is how they're writing their notation. It's called set notation. They make this little set symbol, and they go X, and then this bar means such that. So X such that, and then it's all real numbers, and then they close it up. I'm going to show you another way of how to do this notation that they're going to start next year. It's called interval notation. If something goes forever to the left, that means it goes forever into all the negatives, called negative infinity. If a graph goes forever to the right, then it goes forever, it gets bigger and bigger and bigger and bigger to positive infinity. So this graph is going from negative infinity to positive infinity. Because right here my x is a 1 and here my x is a 0, but here my x would be a negative 1 and here my x would be a negative 2 and then my x would be a negative 3. And then I'd keep going and it'd get more and more negative forever and ever. So it goes to negative infinity and then it gets bigger, 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 bigger. So it goes to positive infinity. So interval notation would be it goes from negative infinity to positive infinity. So next year you're going to start talking about interval notation, and so I just wanted you to see it. So if you see it next year, you'll be like, oh, hey, I kind of knew about that.
So we could just put all real numbers, pretty much.
I want you to know both. That's why I'm showing you both. If I just wanted you to put that, that's all I would have done. Okay, range. Range is about y's. You know how the y-axis runs up and down? So I want to know what this graph is doing up and down. Would you say that the graph goes forever up? Okay, does the graph go forever down? Okay, so what's its lowest y? The lowest y is a 0. The x here is a 2, but the y here is a 0. So the lowest y is a 0, and then the y's get bigger and bigger and bigger and bigger and bigger and bigger, right? Okay, so, no. It's not all real numbers because it didn't go forever up and forever down. If it went forever up and forever down, it'd be all real numbers. But the lowest y is a 0. You don't see any parabola down here, do you? So the lowest y is a 0, and then it gets bigger. So we say y is exactly a 0 or bigger than 0. Y is greater than or equal to 0. And the notation they've been using this year is the little set symbol, and then y such that y is greater than or equal to 0. Okay, interval notation. Are you guys doing interval notation in pre-AP? No? Okay. So interval notation, the lowest y is 0, and then if they get bigger and bigger and bigger and bigger and bigger, would you say that that would be going to positive infinity or negative? Positive infinity. Okay. Now, the difference here is since the y does get to a 0, it is a 0, I use a closed bracket like that. It starts at 0, and then it goes up, 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 so it goes to infinity. The infinities will always get a parenthesis, and that is the correct way of saying only one. Infinity will always get a parenthesis because you can't ever get to infinity. But because it does actually get to the 0, we use a closed bracket. And if this is confusing to you, I don't want you to be overwhelmed about it, because you're going to see it next year. I'm just trying to give you a heads up, so next year might be slightly easier. That's all. Okay, one other thing I want to do that's not listed on here. I want to write down what the zeros are, which are also called x-intercepts, which are also called roots, which are also called solutions. I'm not going to write all 4 of those from here on out, but those are the 4 names that Haley mentioned a minute ago. Zeros, x-intercepts, roots, and solutions. They all mean the same thing, and it's where the graph touches the x-axis. Where did this graph touch the x-axis? And what's the ordered pair? 2, 0. You go right 2 to get there and don't go up or down. So 2, 0 is the 0, the x-intercept, the root, the solution. Was that one fun?
No. Okay.
All right, they get better. The first one always takes longer to explain. Okay, on this one, the vertex. Can you tell me without me telling you?
3, 2.
3, 2. The vertex is this guy right here. And that is the ordered pair 3, 2, because you go right 3 to get there and up 2. Would you call this a max or a min? It's a min. It's the lowest point on the graph. Now, when you do max or min, you want to know how high or how low you are. So you want the y value. What's your y value right here? 2. So the min value is a 2. Okay, remember the axis of symmetry is the vertical line that splits the parabola in half. It always goes through the vertex. What would the equation of that line be? X equals 3. All vertical lines are x equals, and everywhere on that line, the x has a value of 3. Okay, P and Q, it wants to know where's he land when you flip him over the axis of symmetry. So P has to cruise 1, 2 to the right to hop on the axis of symmetry. So 1, 2 more to the right, and this is his new point. And that's 5, 6. Okay, can you tell me where Q would land if you flipped it over the axis of symmetry?
2, 3.
2, 3. Q would land right here. Everybody okay with that? Okay, so 2, 3. And when we graph on Tuesday, we'll practice that skill. Okay, domain. This is always your x's. What's the graph doing left and right? Does the graph go forever to the left? Does the graph go forever to the right? So it's all real numbers. So one way I'm going to write it, the little set symbol, x such that, and then the all real numbers symbol. Does everybody remember seeing that from your past? Okay, and then since it goes forever to the left, it's hitting all the negatives. Since it's going forever to the right, it's hitting all the positives. So interval notation is negative infinity to positive infinity. Okay, range are your y's. That's what the graph is doing up and down. Does the graph go forever up? Does the graph go forever down? So it's not all real numbers. So what's your lowest y?
Oh, no.
2.
My lowest y is a 2. And then do the y's get bigger or do the y's get smaller?
They get bigger.
So the y starts at a 2 and then it gets bigger than 2. And then to write that the way they've been doing it is y such that y is greater than or equal to 2. Okay, now I want to try it with interval notation. So since it gets to the 2, I'm going to put a bracket at the 2. And then because it goes up, 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 it's going to positive infinity. So it goes from 2 to infinity. Back when Algebra 2 had an EOC, we taught interval notation because we were told that the EOC would probably test interval notation, and I felt like the kids got pretty good with it. Like better with that than they did actually with this. Okay, now this one might throw you a little bit for a loop when I get there. Oh, I forgot. Our zeros. I'm only going to write zeros this time, but remember they're also called x-intercepts, roots, solutions, etc. Where did my parabola touch the x-axis?
No, it didn't.
It never did. Here's the x-axis. This did not touch the x-axis at all, so there's none. There aren't any. There actually are solutions, but the solutions are the imaginary solutions that you learn about later.
Later, like this year later?
Later, like in Algebra 2 later.
Oh. I'll have to worry about that.
Okay, next one. What would you say the vertex is? 0, 8. Would you say that that's a max or a min? A max. It's the highest point, so it's a max. And max and min, I want to know how high, how low. So how high am I here? 8. So it's always the y value for the max and min. Okay, axis of symmetry is the vertical line that splits that parabola in half. What would you say it is? X equals 0. Good. Okay, and then P, where do you land when you flip him over?
That would be 1, 6.
1, 6. Very good. He'd land right there, which is 1, 6. And where would Q land if you flipped him over? Yeah, negative 2, 0. Q would land right here. Anybody need me to explain those? Okay, now this parabola happens to be going upside down, but domain and range, we still talk about the same. So domain are x's left and right. Does this graph go forever to the left? It does. Does the graph go forever to the right? Then it's all real numbers. So x such that all real numbers. So what would you say for interval notation? Yeah, negative infinity to positive infinity. If you haven't noticed, all parabolas that open up or down will look like that. Now in Algebra 2, and I think it's still going to stay that way, you're going to start learning about sideways parabolas, and that's different. But parabolas that open up and parabolas that open down, the domain is always all real numbers because those will always go forever left, they'll always go forever right, always forever left, forever right. Doesn't matter if they open up or down. Okay, now range. Does the graph go forever up? Does the graph go forever down? Okay, so where's my y start? My y starts at an 8. Do the y's get bigger than 8 or smaller? Okay, so I say that the y's start at an 8 and then they get smaller. So y such that y is less than or equal to 8. Now, interval notation. We need to think about this for a second. One thing about interval notation I haven't told you yet is the smallest number goes first and the biggest number goes last. So my y starts at an 8, and then if the y's get smaller and smaller and smaller, are you going to positive infinity or negative infinity? So it starts at an 8 and it goes to negative infinity. Which number do you think is smaller? So negative infinity goes first and the 8 goes last. And because it does get all the way to the 8 gets a bracket. But you can't ever get to infinity, so infinities always are a parenthesis. So instead of saying 8 to negative infinity, you always do the smallest number first, biggest number last. Okay, and then let's talk about the zeros. Zeros, roots, solutions, x-intercepts, blah, blah, blah. Can you tell me what one of them happens to be? Negative 2, 0. That's one of our zeros. And the other one? And a positive 2, 0. So those are our roots, our solutions, our x-intercepts, and our zeros. Okay, I want to see if you can do 4 all by yourself. Take a second and try that.
Can you do 4 all by yourself?
What, hon?
Can you do 4 all by yourself?
Of course I can. I already did. Yeah, I did it yesterday all by myself. See? What are you doing with those scissors? That seems dangerous.
Kenzie, don't cut yourself.
I'm against cutting.
Or Kenzie, you know, she might go crazy.
I don't want to cut. That's what I'm saying.
I don't know. You're a mysterious person and special. You're special.
Thanks.
Not like that.
No, it is like that.
Miss Wood, how are you going to make me do this on my own? Like she just did.
Well, I want you to try. It doesn't hurt.
Yeah, but I'm confused.
Oh. Oh, I didn't ask you. Oh, I didn't have a P and a Q. Oh. You have less to do. Also do the zeros. I didn't give you points to flip on this one. My bad. That's okay. We can work on that skill Tuesday.
Vertex is the point, right?
It's not that bad. The first one's confusing, but then it gets easier. Don't you feel like it's easier than the first one? Except Faith.
I'll pay attention. I just don't know.
So would it be -2, -2?
And I'm special.
Kenzie, you ask me for my homework all the time.
No. I do it.
Yeah, Kenzie cheats.
No, I don't. Y'all cheat.
Oh, what's an access of a symmetry? I just forgot.
Well, look back.
I didn't write. I was watching you. Oh, here it is.
Okay, there's no rewards in my name calling here. I just want to see what you
Yeah,
got.
well, call me for the first one.
Are you guys ready? TJ! What's your vertex?
-2,
-2, -2. Correct. That's that guy right there. Did everybody get it?
Yeah.
Bray. Max or min?
Max.
And what would you say the max value is?
-2.
-2. Very good. Okay. Axis of symmetry. Christian.
I got x equals -2.
Beautiful. The axis of symmetry is the vertical line that splits the parabola in half. It's always x equals. We'll talk more about that Tuesday. Okay, domain. Alexis. Give me something. One way of writing it. Domain is about x's, left and right. Does the graph go forever to the left?
Yeah.
Does the graph go forever to the right? What do we call that, Alexis? All real numbers. So it's the little set symbol, x, such that all real numbers. Okay, now I want interval notation, so I'll draw somebody else. Interval notation, Riley.
Well,
Okay, negative infinity and then infinity.
Yeah, it goes from negative infinity to positive infinity. Okay. Range. Cormac.
Me.
I'm not here for crying out loud. Kim. Can you try the one that goes y such that
Y is less than or equal to negative.
y is less than or equal to negative 2? Good. Your y value starts at a negative 2 and then it gets smaller, 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 smaller. So y is less than or equal to negative 2. Very good. Okay, and then let's see if this person can give that to me in interval notation. Cheyenne. It goes from negative infinity to negative 2. And because it does get to the negative 2, it touches it, that's going to get a bracket. Okay, and then zeros goes to Harris.
I mean, it didn't really cross the axis, so I mean,
So you would write
None.
none. You can say no zeros if you wanted to. So none. It never touched the x-axis at all, so there's none. Was that fun? How about your whiteboards? Do you guys have supplies?
No.
Well, let's find them. I know some got picked up yesterday afternoon by the